Hello, and welcome to another lesson from Level 11 Mathematics. In today's lesson, we will be solving equations involving rational exponents. Now, before we start that process, let's look at a few steps. So, to solve an equation that has a rational exponent, the first thing you want to do is isolate the term that's raised to the power. Step 2, you'll raise each side of the equation to the reciprocal of that power. Reciprocal. Step 3, use plus or minus to represent the solution if both sides are raised to an exponent with an even denominator while solving. And then step 4, check for extraneous solutions. Now, these steps are going to make a lot more sense after you see them in action, okay? So in example 1, it says solve each of the following. And we have the expression 3x plus 1 raised to the 1/3 power is equal to -5. Now, in this problem, step 1 is already done for you. The expression being raised to the rational exponent is already isolated. So I can skip right to step 2, which says raise each side of the equation to the reciprocal power. So I'm going to have 3x plus 1 to the 1/3 power, and I want to raise both sides to the reciprocal power. Now, the reciprocal of 1/3 is 3/1. So I'm just going to raise both sides to the 3 power. So when I do that, 1/3 raised to the 3 power is just 1. So this would be 3x plus 1. You might want to use your calculator to evaluate this one, and definitely use parentheses. -5 raised to the 3rd power. That's equal to -125. Now, once you do that, I hope you can see that you have a simple 2-step equation like you probably learned in 7th grade. So we're just going to get the x by itself by subtracting 1 and then dividing by 3. So when I subtract 1, I get 3x equals -126, and then divide by 3. -126 divided by 3 gives me -42. Now, I don't want to box that in yet, because sometimes when you're solving equations with rational exponents, you get something called an extraneous solution. Now, to check if it's extraneous, what I want to do is go back to my original problem, and I want to plug in a -42 for the x. And when I do, I should get out a -5. I should get out a -5. So let's try that. I'm coming over to my calculator, parenthesis 3 times, and instead of x, I'm going to put my solution, which was -42, plus 1, close parenthesis, and I want to raise that to the 1/3 power. So I'll use a parenthesis for the 1/3 power, so 1/3. Now, when I do that, my calculator says that I'm going to get -5, and that's exactly what my original problem said I should get, so I know this is a true solution of this equation. All right, problem B. We have x minus 1 to the 2/3 power is equal to 16. Now, pause the video and try this problem on your own. All right, welcome back. Let's see how you did. All right, what I did was I took this expression, x minus 1 to the 2/3 power equals 16, and I raised both sides to the reciprocal power. Now, the reciprocal of 2/3 is 3/2. Okay, the reciprocal of 2/3 is 3/2. Now, when I did that, that gave me x minus 1 equals. Now, there's one thing you might not remember from your steps. When you raise something that has a power to an even denominator, let's see, like right here, we're going to use our plus or minus symbol. So x minus 1 equals plus or minus, and I want to take 16, 16, and raise it to the parenthesis 3/2 power, and that gives me plus or minus 64. All right, now I'm going to solve that equation by adding 1 to both sides. So x equals 1 plus or minus 64. So I'm going to get two solutions here. 1 plus 64 is 65, and 1 minus 64 is negative 63. All right, now what we're going to do is we're not going to box in these answers until we check them. So remember, in this problem, here's your original expression, x minus 1 to the 2/3 power, and they want that to equal positive 16. So both of these answers may work. None of the answers will work, or maybe only one of them will work. Let's try it and see. So going back to my original problem, parenthesis, instead of x, I'm going to put my first answer, which is 65 minus 1, close parenthesis, raised to, parenthesis, the 2/3 power, and that gave me 16. So I know I have this as a solution, but now let's check if negative 63 would also be a solution. So delete the 65, put negative 63, and that is also equal to 16. So both of these solutions were true solutions. So I'm going to box both of them in. All right, problem C. We have 4x to the 3/2 power minus 32 is equal to 0. Now, in this problem, your expression that's been raised to the rational exponent is right here. We want to isolate this x. So I'm going to have to add 32 and then divide by 4. Add 32 and divide by 4. So when I add 32, I get 4x to the 3/2 power equals positive 32. Now we're going to divide by 4. So x to the 3/2 power is equal to 32 divided by 4 gives me 8. Now I'll raise both sides to the reciprocal power. So the reciprocal of 3/2 is 2/3. Now let's talk about if we need to use plus or minus in this problem. So if I'm looking at my power that I raised here, the denominator is 3, which is an odd number. So I do not need plus or minus here. So this will be 8 raised to the 2/3 power, which is 4. Okay, again, do not box it in though until you check it to see if it's extraneous. So we have 4 times our solution raised to the 3/2 power. I need to side arrow here. Side arrow. Minus 32, and I want it to equal 0. And sure enough, it does. So that means we can box this answer in. All right, in problem D, we have 2 times the quantity x plus 3 raised to the 4/5 power minus 1 is equal to 31. So let's talk about what we're trying to isolate here. The expression with the rational exponent is right here. I want to get that by itself. So I'm going to have to add the 1 and then divide by 2. Add the 1 and divide it by 2. So 31 plus 1 will give us 32. So 2, parenthesis, x plus 3 to the 4/5 power equals 32. So I added the 1. Now divide by 2. So 32 divided by 2 gives me 16. So this will be x plus 3 raised to the 4/5 power is equal to 16. All right. Now I want to raise both sides to the reciprocal power. So box it in, box it in. So the reciprocal would be 5/4, 5/4. All right, now let's talk about if we need plus or minus. So look at the power we just raised it to, and look at the denominator. The denominator is 4, which is even. So that means we will need the plus or minus here. So x plus 3 is equal to plus or minus. Now let's see what 16 raised to the 5/4 power is. So plus or minus 32. Now, to solve the problem, we'll subtract 3 from both sides. So this would be negative 3 plus or minus 32. So we're going to get two solutions. So negative 3 plus 32 would be positive 29. Negative 3 minus 32 would be negative 35. All right, now let's check that answer here. So I'm going to go back to the original problem, put in 2 parentheses. Instead of x, I'll put my first solution, which was 29, plus 3, close parenthesis, raised to the 4 over 5 power, side arrow, minus 1, and that equals 31. So first answer, box it in. Now change that 29 to a negative 35. And that gives me 30. Oh, wait. That also gives me 30. So now we have another true solution. All right. Our next problem, we have x plus 3 raised to the 1/2 power is equal to x plus 3. So in this problem, our expression is already isolated. So I can skip straight to the second step. Let me rewrite this here so I have a little room. The second step says I'm going to raise both sides to the reciprocal power. And the reciprocal of 1/2 is 2. So I'm going to square both sides. Now when I do that, on this side I get x plus 3. And on this side, x minus 3 quantity squared would be x squared minus 6x plus 9. Now, this is the first problem we've had that's not a linear equation. This is a quadratic equation. And I generally try to solve these by factoring, but that's because I'm pretty good at factoring. You could also use quadratic formula. For this lesson, I'm just going to use factoring to solve it. So I want to get all the terms on the same side. So I'll subtract x from both sides, subtract 3 from both sides. Okay. When I do that, the side is left with 0. Over here, I would have x squared minus 7x plus 6. Now I'll try to factor this expression. So for x squared, I'll use x times x. For 6, I'm going to use 6 and 1. I'll make them both negative, so they'll add up to negative 7. So my two solutions are x equals 6 and x equals 1. Again, just like all the other problems, we're going to check them. The only thing is, on this side, I want this side, x plus 3 to the 1/2 power, to equal this side. So, parenthesis, instead of x, I'm going to put my first solution, which was 6. Whoops, I need my parenthesis. Parenthesis 6 plus 3, close parenthesis, raised to the, I'll use 0.5 power instead of 1/2, and that's equal to 3. Then I'll plug in the other side. X minus 3 would be 6 minus 3. So they're both equal to 3. So I know 6 is a solution. Now I'm just going to change the 6 to a 1. So put a 1 there and a 1 here. So the left side equaled 2, the right side equaled negative 2. So this is, the x equals 1 is an extraneous solution. So our only answer here is x equals 6. Okay. All right, problem F. We have 3 over 2 times the quantity x plus 9 to the 3/5 power is equal to 12. Now, I want to isolate, let's see, where's my highlighter? I want to isolate just this expression. So I need to get rid of this 3 over 2. So I'm going to divide both sides of this equation by 3 over 2. So x plus 9 to the 3 over 5 power equals, I want to take 12 and divide it by 3 over 2. And that gives me 8. So x plus 9 to the 3/5 power is equal to 8. Now, raising both sides to the reciprocal power, which would be 5 over 3. Now, I want you to think about this for a minute. Should we use plus or minus here? And the answer is no, because our denominator was odd. So we're not going to need a plus or minus symbol. This would be, whoops, I want that to be in blue. So this would be x plus 9 equals, over here, parenthesis 8, parenthesis to the 5 over 3. That would be 32. And then just subtract 9 from both sides. So 32 minus 9, let's see, 32 minus 10 would be 22, 23. Now we're going to check our solution. So 3 over 2 parenthesis. Instead of x plus 9, I'll put 23 plus 9. And I want to raise that to the 3/5 power. And I get 12, and that's what we were supposed to get. So this would be a solution to our equation. All right, now we can also solve these problems graphically. And hopefully you've seen this before, where we're going to use our calculators to graph the expressions to find the solutions. Now, here's the steps. You're going to graph the left side of the equation as function 1 in your calculator. You'll graph the right side as function 2 in your calculator. You'll identify the points of intersection, and then the x values will represent your solutions. So in problem A, we have x to the 3 over 2 power equals 8. So function 1 would be y equals x to the 3 over 2 power. Function 2 would simply be y equals 8. All right, so I'm going to come to a graphing calculator, and I'll type in my first function, x raised to, now 3 over 2 is the same thing as 1.5, so just to save time, I'll just put this in as x to the 1/5 power. So that's on line 1. Now, go to a different line, line 2, and type in y equals 8. Now, you can see that they intersect here. And so I'm going to put my finger on it. It intersects at 4, 8. Now, what I want to do is just draw a rough sketch of this. So my first function kind of went like this. Then my second function kind of went like this, y equals 8. Then they intersected right here at 4, 8. So my point of intersection, we only had one in this problem, so I know there's only going to be one solution. My point of intersection is 4, 8. But my solution to this equation is x is equal to 4. Now, I will just show you that when we check it. So my original problem was x to the 3 over 2 power should equal 8. Well, let's see. Let's plug in our solution and see if that's true. So I'm going to take 4 raised to the 3 over 2 power. And sure enough, I get 8. So this is a true solution here. So x is equal to 4. All right, pause the video and try problem B on your own. All right, welcome back. Hopefully you wrote that function 1 was y equals 4x to the 2/3 power. Function 2 was y equals 36. So when I come over here to graph this, 4x to the 2/3 power. Oh, let me get rid of my other graphs here. Let's see. Okay, so now I've got this very interesting, funny shaped graph here, 4x to the 2/3 power. And then I've got my second function, which is y equals 36. Now, 36, I'm going to have to really zoom out to see that. Okay, there we go. All right, so we're in this problem, you can hopefully see that you have two solutions. One is right here, so I'm going to tap on it, and one is over here. All right, so let me try to sketch this here. This is kind of an interesting graph, kind of looks like that, and then like that. Well, that's not a straight line, so let me try that side again. Kind of look like that. It's going off that way. This is going off to the right. And then it has a horizontal line at 36, so something like this. So you're going to have an intersection here and an intersection here. So our intersection points, there are two of them, negative 27, 36, and positive 27, 36. So our solutions will be plus or minus 27. We have two solutions, so we need to make sure we include both of them. All right, last example. You are installing a cable from a power station to a remote location to provide electricity. The cable follows a direct path underground. The depth of the cable below the ground surface is given by the equation d of x is equal to 20 times x to the 1/2 power plus 10, where d of x is the depth in meters and x is the horizontal distance from the power station. If the cable needs to be buried 50 meters below the ground at a specific point, find the horizontal distance. So they gave us, let me find a different color highlighter, they gave us the depth, which was 50 meters. So into this equation, d of x equals 20 times x to the 1/2 power plus 10, I'm going to plug in a 50 for the depth. So 50 equals 20 times x to the 1/2 power plus 10. Now, if it makes you feel better, you can rewrite this to look more like the equations we had on the other side. 20 times x to the 1/2 power plus 10 is equal to 50. So what we want to do is get this expression right here by itself. So I'm going to have to subtract 10 and then divide by 20. Subtract 10 and then divide by 20. So when I subtract 10, I would get 20 times x to the 1/2 power is equal to 40. 50 minus 10. Now I'll divide both sides by 20. So 40 divided by 20 gives me 2. So x to the 1/2 power equals 2. Now raise both sides to the reciprocal power. So this would give me x, and 2 to the 2 power would give me 4. So the horizontal distance, let's see, the distance was measured, I believe, in meters. So this would be 4 meters. And that concludes today's lesson, solving equations with rational exponents.